Okay, so in this video we will talk about common value auctions. They're different from private value auctions in that valuations here will be correlated. So my value of a good will also depend upon the signal that you've received about that good. So think of something like an oil field or real estate. Let's say I want to invest in real estate. Your signal regarding the potential value of that good is informative to my valuation of that good. In particular, my valuation will be given by a valuation function gi, which depends upon t1, t2, all the way up to tn, where ti is the signal that player I receives. Right? So my valuation will depend upon all of the signals of everyone. To be fair though, I will not observe everybody else's signals. I will only know that my valuation depends on them. This also doesn't imply that everyone has the exact same valuation for the good. That's a special case of this, and that's an example where, let's say, what I care about is the number of barrels of oil that are available in a particular tract. Here, this GI is more general than that. It merely captures correlation and not exact equality. Exact equality will be a special case. The other thing that I want to define before we define the game is P of B. That's basically some price which is a function of B1, B2 up to Bn, where these B's captures the bids that players 1, 2, 3 and so on put in. This PB is the price that the winning bidder pays. So the person who bids the highest, they pay a price PB, which depends upon the whole profile. And so that can capture first price, second price, third price, all kinds of auctions. So that we don't have to define the game twice, basically. Now let's define the game a little more formally. The set of players here is the n individuals. The states. So each signal profile will be a state. So the states are just all profiles T1, T2, up to Tn, where these are just signals, these are valuations. Each of these states is different, right? Then the next thing I want to describe is actions. An action here for each player I is just the bid, which is going to be some positive real number, or non-negative real number rather. And then signals. The signals will be defined by some signal function ti, tau I rather, sorry, where tau I takes the state of the world, which is this profile, and generates simply the signal for player I. So what that means is that for any state of the world, which is this profile, the signal function provides to player I only player I's valuation and not anybody else's. Then what I need is beliefs. We haven't yet described any distribution from which TIs are generated. Assume some underlying set of distributions from which each TI is generated. We're not going to bother with specifying that for now. The only thing you need to know is that all TIs are generated independently. They may all come from the same distribution, they may all come from completely different distributions. doesn't matter too much. Then there's the payoff function. As player I, my payoff can either be this valuation gi of the state of the world, which depends on the state of the world, minus the price that I have paid, divided by m, if bi is at least as large as all bj, and bi equal to bj for m like right. So if there's a tie, so if there are, like, let's say 2 people who bid the highest, then m equals 2. If there's just 1 person that bids the highest, then m equals 1. That would just be bi equal to bi. And this just says that bi is one of the highest. And it captures both the situation where player I wins outright and the situation where player I ties with m other individuals. Or rather, m minus 1 other individuals. And then 0 if some bj is greater than bi. Right? If there's any player who has bid higher than player I does not get the good. Player I also then doesn't have to pay anything, and so player I gets 0. So that completes our definition of this Bayesian game. What we'll do next is consider possible equilibria in this game. So that's what we'll do in the next video. See you.